Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining about object orientation. Once I start the explanation of object orientation, you will come to know about what is an object and what are the methods, right? So along with that, I am also going to explain about the characteristics that are required by an object orientation approach. So once I explain these characteristics also, you will come to know more about the object oriented concepts, right? If you are not subscribed to my channel, please subscribe to my channel, and please don't forget to like the video, and please don't forget to share the video with your friends, and also to get the notification of my new videos, please click the bell icon. So let me begin the explanation of object orientation. Also, along with the object orientation, I'm going to explain about the characteristics also, right, that are required by an object orientation approach. So what is object orientation? It is very simple. So if you want to develop a software, right, how you are going to develop a software means using a SDLC, right, software development life cycle. So SDLC means what? It is a process to create a software, right? I can't create a software. I need some planning, right? So SDLC is a plan. So I explained about a waterfall model, spiral model, those things. If you want to know more about that, so the link is in the description, right? So you know that SDLC is used to create the software. But what is object orientation? In object orientation, I am going to organize my software as a collection of objects. Here I am going to create my software by seeing the software as an object. Each and every component in my software will be considered as an object. For example, assume that I am developing a software for railway ticket reservation. I am developing a software for railway ticket reservation, and assume that it has three features. I can book a ticket, I can cancel a ticket, and I can view the information of the customer, right? So this is my software. Here, so object orientation means I'm going to consider my each features as objects. So canceling a ticket will be considered as one object, booking a ticket will be considered as one object, viewing the information of the information of the customer will be considered as one object. So what I'm trying to say is, whatever the components are there within your software, all those components will be considered as a collection of objects. Each and every component is an object. Hope you understand. That is object orientation. You are going to use this concept of objects from the first step to last step, right? From first to last step, you have to consider each and everything as objects. That is object orientation. So once I start explaining the characteristics, you will get more idea about this. So far, object orientation means if you want to create the object, you should consider this. If you want to create the software, you should consider the software as a collection of objects. Your software is should be considered as a collection of discrete objects. That means different objects, right? So what are the characteristics that are required by object oriented approach? So the four characteristics that are required by object oriented approach. As I said, once I explain these characteristics that are required by your object orientation approach, you will understand more about object orientation. So what is the first characteristic? Identity. The second characteristic is classification. The third characteristic is inheritance, and the fourth characteristic is polymorphism. So these are the four characteristics that are required by object orientation. Now I am going to discuss each characteristics in detail one by one. So identity. So what is identity? Identity means that the data is quantized into discrete distinguishable entities called objects. Here I already told you. Here, if you are developing a software, you have to assume that each and every components of a software as objects. So what is objects? Objects are distinguishable entities. right? For example for objects, whatever you see in this real world, each and every component in this real world can be considered as an object. For example, our computer, personal computer can be considered as object. Bicycle, right? Our fan, light, television, whatever you take, you have to consider each things as objects, right? If I say a object can be concrete such as file in a file system, or conceptual such as scheduling policy in a multiprocessing OS. Conceptual means you can't touch the scheduling policy. Can you touch the scheduling policy? Scheduling policy is just an idea. It is just a logic. You can't touch that. Scheduling policy is also object only, right? But you can't touch it and you can't feel it. That's why it is conceptual. Concrete means you can touch it. File you can touch it, right? So object can be concrete or object can be conceptual. Hope you are understanding. And one more thing, file in a computer also a concrete only. File in a computer system, why it is concrete? You can't touch that file in a computer, but you can see it. You can see it. That's why it is a concrete. But scheduling policy, can you see it? No, scheduling policy, you can't see it. Hope you are understanding, guys. It is conceptual, right? If you can see, you can tell that object as concrete. For example, computer is a concrete object. Bicycle is a concrete object. You can see that, right? Hope you are understanding. Pythagoras theorem, it is also considered as an object, but it is conceptual. Hope you are understanding. And one more important thing, each object has its own identity. Each object has its own identity. Suppose if you have two personal computers, each personal computer is different. If you have two bicycles are different. They have their own identity. For example, two objects are different even if all their attribute values are identical. For example, I told you, I have the two PCs. How many PCs? Two personal computers. Same configuration. Even I have two PCs with the same configuration, I can't tell that PCs as same. No. Two PCs. They are different. If I have two fans, fan is also same object. Same color, same rotating speed. But the fans are different. Two different fans are there. Hope you are understanding. See, once again, see here, cycles. For example, bicycle. Two bicycles are there. Same color, same characteristics, same size, but these two bicycles are different. Hope you are understanding. Right, guys? Hope you are understanding, right? In programming languages, if you want to refer the object, you can use some addressing mechanism. Each object will have some address. You can use this address to identify that particular object in programming languages. Hope you are understanding. So far you should know that object can be a entity, distinguishable entities, discrete entities. Anything you can consider as an object here. Object can be concrete, object can be conceptual. And each object will have their own identity. If you have two fans, that particular fans are different. If you have two books, one book is different from other. Hope you understand. Next, classification. Classification means the objects with the same data structure, that is, the object with the same attribute and the behavior are grouped into a class. For example, objects with the same characteristics are grouped into a class, right? And each object is said to be an instance of its class. Don't get confused here. Objects with same characteristics, that is same attribute, same behavior, can be grouped into a class, and each object in the class can be called as instance of its class. So best example, see here, polygon class. Polygon class, you can see here triangle is there, the triangle is also a polygon. Rectangle is there, the rectangle is also a polygon. Rhombus is there, rhombus is also a polygon. Triangle, rectangle, rhombus, all these three objects belong to a same class called polygon. Why? These attributes of this particular objects are same. For example, vertices are same, border is same, fill color attribute is same. You can see how many vertices are there for right, sorry, no, don't get confused here. For example, triangle also uses vertices, rhombus also uses vertices. We need vertices to create these objects. Again, rectangle also have the vertices. Hope you are understanding. Border class. Again, rhombus will also have border, triangle will also have border, rectangle will also have border. Fill color. You can fill any color to the triangle also, you can fill any color to the rhombus also, you can fill any color to the rectangle also. Hope you understood, right? So all these objects, rhombus, rectangles, all these objects need vertices, they need border, they need color. That's why all the attributes are same, all the characteristics of these objects are same. That's why I can group this as a class. All these objects belongs to a class called polygon. In the same way, all the operations that can be done by these objects are also same. For example, you can see there operations draw, erase, move. I can draw the rectangle, I can draw the triangle, I can draw the rhombus. In the same way, I can erase the triangle, I can erase the rectangle, I can erase the rhombus. In the same way, I can move the rhombus, I can move the triangle, I can move the rectangle. You can see there all the operations also same. I can do all these operations on all these objects, right? That's why I can group all these objects as the same class. The operations that are supported by these objects are same, the attributes that are supported by these objects are same. That's why I can group all these objects, right, to a same class. So attributes are nothing but right, attributes are nothing but I can call the data structure. Attributes can be also called as data structure, and operations are also called as behavior. You can see there all the data, vertices, border class, fill color, all the data for this right can be same, for these objects can be same. In the same way, all the operations can also be same for this. That's why I can group them as a class. In the same way, bicycle class, you can see their attributes, frame size, wheel size, number of gears, material, all these attributes for this bicycle class remains the same. Again, what are the operations? Again, I can shift the bicycle, I can move the bicycles, I can repair the bicycles. You can see there are two bicycles here. For each bicycle, the frame size will be same, the wheel size is also same, gears also same, materials what I used also same. See, again, these two bicycles are having the same attributes, same color, same size. Also same operations applies to these two objects, two bicycles. And these two bicycles are different, you know that. Each bicycle will have their own identity. I can shift the bicycle, I can move the bicycle, I can repair the bicycle. Same operations applies to all these bicycles, two bicycles. So that's why I can group these two bicycles as one class. As one class, right? Hope you are understanding, guys. So what is the next characteristic? Inheritance. Inheritance means I can create two classes here. One class is a superclass and another class is a subclass. Subclass can inherit the features of the superclass. For example, it is the sharing of attributes and operations among classes based on a hierarchical relationship. So hierarchical relationship means what? I can share the attributes and operations, right? So for example, how I am going to share means I will have a superclass and I will have a subclass. Subclasses we are going to share the features of the superclass. For example, vehicle class I will consider. Vehicle is a superclass here. Consider vehicle as a superclass. Scooter is a subclass. Car is a subclass. Hope you are understanding. Vehicle is a superclass. Car is a subclass. Scooter is also subclass. Now, how these two subclasses can inherit the feature of the superclass vehicle? For example, this car will also have the tires. Hope you are understanding. Cars will also have the tire. Scooter will also have the tire. So tire is the feature that can be inherited from my superclass vehicle. Hope you are understanding. So this is nothing but inheritance. I can inherit the features of this superclass. Subclass can inherit the feature of the superclass. Here my subclasses are what? Scooter and car. What is my superclass? Vehicle. Scooter will also have wheel. Vehicle will also have wheel. Car has also a wheel. So wheel feature can be extracted from the superclass vehicle. Hope you are understanding. For example, vehicle will have color. Same color can be extracted for scooter also, for the car also. Hope you are understanding. You can use the same color information. I can use the tire information. I can inherit the tire information. I can inherit the color information for my subclasses scooter and the car from the superclass vehicle. Another example, scrolling window and fixed window are subclasses of a window. You have a computer window, right? Computer screen, right? That is fixed window. That is also a window. Scrolling window means you can move up and down, right? You know that scrolling mouse, you can scroll the window, right? That is also a window only. So your my main superclass is window. Scrolling window is also a subclass. Fixed window is also a subclass, right? My superclass is also a window. My subclass is also a window. They have length, they have breadth. My superclass window will also have length and breadth. Scrolling window can also inherit length and breadth. Fixed window can also inherit the length and breadth. Values. Hope you understand. Right? Next, last characteristic is polymorphism. Polymorphism means same operation may behave differently for different classes. For example, best example for this is move operation behaves differently for a pawn in the carom, and move operation behave differently for the chess. For example, you can move the pawn in the carom, right? Same, you can move the pawn. How you are going to move the pawn? By hitting the pawn with a striker. You are moving the pawn in the carom by hitting the pawn with a striker. That is one. You are moving it. How you are going to move the pawn in the chess? You are going to move the pawn in the chess by using the hands. Hope you are understanding. In carom also you are moving the pawn. In chess also you are moving the pawn. What is the operation there? Moving. Moving is same. Moving is operation, but it differently behaves in a carom, but it differently behaves in a chess. Moving is the same operation. In carom also you are moving. In chess also you are moving. It's the same operation, but you are differently moving in different games. For example, in carom, how you are moving? By hitting the pawn with a striker. In a chess, how you are moving? By moving the pawn with the hands. By moving the pawn with the by moving the pawn with the ants. Hope you're understanding. Move is the same operation, but it behaves differently for carom and it is also behaves differently for chess. Same operation may behave differently for different classes. Hope you understood, guys. Suppose if you have any doubts, please post your doubts in the comment section, right? And also, operation is a procedure, right? It's a procedure that an object performs. For example, you can see here, shift is a procedure that a bicycle performs. Move is a procedure that a bicycle performs. Draw is a procedure that a triangle or a rectangle performs. Your object performs these operations. Your object performs this operation. If you write a program to conduct this operation, and that program is called as a method. Theoretically, I can tell that this is operation. How to execute that operation programmatically means you have to write that method. You will understand this method, right, in a more detailed way in upcoming videos. Hope you understood now. An operation is a procedure that an object performs. How we are going to implement this? Theoretically, it is an operation. Shift. For doing a shift operation, I have to write the code. That code is nothing but a method. You will understand that. Once I explain with the programming concepts, you will understand that, right? So that's it, guys. Hope you understood the concept. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.